Okay, so we have got to mark exercise 5.1. There's number 1A, B, and C. Quickly have a look. Remember, yesterday we said bases must be the same and we must multiply. And if that's true, base will stay the same and we are going to add exponents.
No, ma'am.
What?
I said 3 times and I said 9 and 10. I forgot that they must be 9.
I heard that in the previous class as well. They got confused with the one where I talked about the coefficients may multiply. That's not the same. So before we carry on with the marking, have a look at what we then did. I then added this little step at the end. Remember yesterday when we did law number 1? Multiplying of powers. Have a look right at the bottom. I said very important. Base stays the same. So add that in your list too, please, because I saw that you guys get confused with that. Kazi, you now have 2 marks. Wat's fout, Miss Van? Jy siek, glo nie lekker nie, or just tired. Right, did you all add that?
Yes, ma'am.
Okay, quick. Just write base stays the same. Kazi, shh. Right, so let's mark. I'm just going to talk through the first few and then you guys will see what's happening. So 3 to the power 5 times 3 to the power 5. What I did, have a look at what's written on the board here. I explained it to them like this again. That 3 to the power 5 is the same as 3 multiplied with itself 5 times. So it's actually 3 times 3 times 3 times 3 times 3. Okay? Then times 3 to the power 5. So again, 3 times 3 times 3 times 3 times 3. Now, if you look at it like this is a very long method. So I'm only showing you guys this so you can understand. Right? That is actually 3 multiplied with itself 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So that's why my final answer is 3 to the power of 10. Does that now make sense? And that's also why the base stays the same. It's only the exponent that changes. Okay. Right, so you will see that over here, I wrote it out, 5 plus 5. But you didn't have to. You could have skipped from there to the final answer. Okay? Just for the first few, you'll see that I write that step out. Okay. Right, then at B, they all have a base of 2, and we're multiplying, which means that base will stay 2. There we go. And I'm now going to add all my exponents. So your final answer should be 2 to the power of 11. Okay. Then same thing here. The bases here are all 15. They're all 15. So base will stay 15. All I'm going to do is I'm going to add my exponents. And that means that I get 15 to the power of 12. Remember, we had to keep it in exponential form, no? Okay, any questions so far? Okay, can I skip?
Yes, ma'am.
Okay, there's D, 10 to the power of 9 times 10 to the power of 11 times 10 to the power of 10. So bases are the same and we multiply, which means that base will stay 10, but I'm just going to go and add all my exponents. So it would be 10 to the power of 30. Christopher, what are you doing? Lift up the textbook in front of you. Oh, you're finishing number 3. Homework should be done. No? Number 2. What is my base at number 2A?
Minus 3.
Good. Because there's brackets around, minus 3 is my base. No? So minus 3 will stay the base. And now you'll see I don't write that extra step in between. Because we're multiplying, I know I'm going to add this 2, and that's 3. And that means that I get minus 3 to the power of 5. Now you could have stopped there, but just in case someone went further and got rid of those brackets, a minus multiplied with itself 5 times, meaning minus times minus times minus times minus times minus. Because that 5 is an uneven number, your answer will be a negative. Okay, and then 3 to the power of 5. Any questions there? Then B was straightforward. All my bases were A and I'm multiplying, so I can add exponents. So my answer will be A to the power of 18.
You see, ma'am, I got that one line because the other one.
Because you couldn't multiply. Okay, can I skip? Hands up, we're still copying. Great, okay, there's C, D, and then 3A. At C, I think, or I'm hoping not, but most of you would have forgotten that this is a to the power of 1. Right at the top. That minus A, it didn't have any exponent, but when nothing is written there, it's actually to the power of 1. So, yes, it's always. We don't write the to the power of 1 because we assume. Okay, it's just when it's more than 1 that we write it, like a 2 or a 3 or whatever. Okay, so that's why base will stay minus A, and now I've got to add the exponents. So the 5 plus 3 gave me 8, plus the 1, so to the power of 9. And then this step you didn't have to write, but just in case someone maybe got rid of those brackets, again, because the exponent is an uneven number, your final answer will be a negative again, and then A to the power of 9. Okay, now at D. Are my bases the same? Because over here base is y, and over here it's minus y. So I could not go and add exponents, no. But what I could do is, according to BODMAS, I first got to get rid of my brackets. So that to the power of 6 applies to the negative and to the y. And a negative multiplied with itself 6 times, because that's an even number, it becomes a positive y to the power of 6. And now, once I get to here, my bases are the same. So now I can go and add those exponents, and that's how I get y to the power of 30. Right, any questions? Okay, at number 3, we start getting coefficients. So 4 times 5 gave me that 20. Then a squared and a have got the same base, but that a, someone said it now, has got it to the power of 1. So if I add the exponent, it gives me a to the power of 3. You guys good? Okay. Can I skip? Okay. At B, again, multiply the coefficients. So 8 times minus 2 gave me the minus 16. And then a to the power of 2 times a to the power of 3. Base is the same. And we multiply. So I can add those exponents. And that's how I get a to the power of 5. Okay. Now have a look at C. A to the power of 2, b to the power of 2. Times a to the power of 3, b to the power of 6. Now what I did is I grouped the ones together that's got the same base. So a squared with a to the power of 3. Now those have got the same base, meaning I can go and add them. So that's how I get this a to the power of 2 plus 3. You fine with that? Okay. Then look at the bases that's got a b. B to the power of 2, b to the power of 6. So same base, and we're multiplying, so I can go and add those exponents. That's why I say b to the power of 2 plus 6. So that would be your final answer. Okay. Any questions? Okay. Over here, let's look at coefficients. 2 times 3 gives me 6, times 4 gives me that 24. No. Now let's look at all the a's. A to the power of 3, a to the power of 2, a to the power of 1. So that's how I get a to the power of 6. I added those exponents. Now the b's. B to the power of 1, b to the power of 5, b to the power of 4. So that gives me b to the power of 10. Okay. Any questions? Are you guys okay with law 1? Okay. Now we are skipping to law 2. Anyone still copying? Copy, please. Right, so now we are busy with law number 2. So please copy from the slide. Law number 2 is about dividing powers. Okay, now I'm just giving you a few steps again. Step 1 would be bases must be the same. Step 2, bases must be the same, and then we also dividing. Now, if those are true, then at number 3, you'll see then we subtract the exponents. Yes. Law number 2.
So this still applies to the same thing, just adding.
Yeah, it's still exponents, but it's now a different law. The previous law, base was the same when we multiply. But now, base is the same and we divide, yeah. Okay, so we said we're going to subtract our exponents. Now then I say, very important, top minus bottom. Now I'll explain that again when we get to that, because sometimes they give it to you in the form of a fraction. Okay, but you'll see when we do the exercise. And then right at the bottom, please remember that base stays the same. Okay. Sure. It's not often we have this type of silence. So lekker. Julle spoil dit vir my. Dit is so lekker. Ja. Ja. So it's still part of number 3. Yeah. But you'll see when I mean what I mean with that once you, okay. Okay, hands up who is still copying. Okay. Tell me when you're done, Christopher. Okay. But once we're done with this, then I'll call you one by one and then you can check. Right, you're done. Okay. Let's look at people. Yeah. Yes. Okay, so let's look at a few examples. The first one, now keep those rules in mind. No? The first one says a to the power of m divided by a to the power of n. Now, first things first, base is the same. We are dividing, so what do? Minus exponents. My base will stay a, stays the same. Now, I must minus exponents, so m minus n. And that is the answer. Because we didn't have any numbers here, that's as far as we can go. Okay. Now, number 2, 7 to the power of 12 divided by 7 to the power of 7. Base is the same, and we're dividing. So we can say 7 to the power of 12 minus 7, which means my final answer will be 7 to the power of 5. Do you guys get that? Okay, can you see base stays 7? No, it stays the same. It doesn't change. Right, now this blue one is what I was talking about with top minus bottom. So what's actually written here, and don't write it down, I'm just going to quickly show it to you guys. X to the power of 6 over x to the power of 2 is actually the same as x to the power of 6 divided by x to the power of 2. So it's just a different way of writing it. No. Okay, now, when we get this, we would still, okay, are my bases the same? Yes, and we are dividing. So base will stay x, and we're now going to subtract exponents. And this is what I meant. We take the exponent at the top, meaning the 6, and minus the exponent at the bottom, meaning the 2. So your final answer will be? Good. X to the power of 4. Now, people, I just want to mention, you might get sums where the top exponent is smaller than the big exponent, bottom exponent. So let's say that those numbers were switched around. The 2 is at the top and the 6 was at the bottom. It's not wrong. Your final answer will just then be x to the power of minus 4. You can have a negative exponent, no? So it's not necessarily wrong. That's why I'm writing it down and saying, always remember top minus bottom. Okay. Now, number 4. What I'm throwing in here is coefficients. It's the same as what, forget about those A's. Let's say I only gave you 56 over minus 8. What would you have done then if I said simplify? Calculator, and how much does it give you? Minus 7. No. Okay, so it would be minus 7. Now, look at the ones, it is right. Look at the ones that's got a. A to the power of 5 over a to the power of 2. That's the same as a to the power of 5 divided by a to the power of 2. And is base the same? Yes, and we are dividing. So my base will stay a, and because we're dividing, I'm going to take top exponent minus bottom exponent, which means that my final answer will be minus 7a to the power of 3. Do you guys understand that? No questions? Okay, are you still copying? Yeah? Go away. No, the bell's going to ring just now and then you can go. Yeah? Signing up to... What period is it now? 4. Okay, wait. Are you all done copying? Yes. Write down, please. Yeah. I never forgot. Oh, man. I can't hold it. Okay. Right. Shh. Listen. Hey. What? Right now I'm waiting. What is my base here? XY. Okay, the full XY. Now, at the bottom, I've got no exponent, but we just said there's, yeah, what now? So that's actually to the power of 1. Now, people, we just said that when base is the same and we divide, base will stay the same. So my base will still be xy. And now we take top exponent minus bottom exponent. But is that correct? What's missing? the brackets. Because, have a look. If I do not put brackets around, it looks like this exponent only applies to the y. Okay, so I have to have brackets around. So your final answer will be xy in brackets to the power of 3. Any questions?
No, no.
Let's say, you guys, can you please be quiet? While I'm talking, I don't want anyone talking. It's very rude. If I ask you to get rid of those brackets, remember that 3 applies to everything in the bracket. So that would be the same as x to the power 3, y to the power 3. No? Okay. Right. So any questions about dividing powers? Okay. Then your homework will be exercise 5.2. That is on page 43. You're going to do number 1 up until 3. Yes.